Hello students, now we solve question number 24 from section A. This question is given from real analysis and this question is based on continuity of a function, continuity and discontinuity of a function. So the question is, consider the following two statements. So here two statements are given. Statement P, there exist functions f r to r, g r to r such that f is continuous at x equal to 1 and g is discontinuous at x equal to 1, but their composite function g of f is continuous at x equal to 1. Statement Q, there exist functions f r to r, g r to r such that both f and g are discontinuous at x equal to 1, but their composite function g of f is continuous at x equal to 1. So which of the following holds? Here four options. Option A, both P and Q are true. Option B, both P and Q are false. Option C, P is true but Q is false. And option D, P is false but Q is true. So let us find the functions f and g where and whether we check the statements P and Q true or false. So for statement P, let us consider the function f r to r given by defined by f of x is equal to sine 1 by x, which is continuous at x equal to 1, because limit x tends to 1, f of x is equal to f of 1. So f is continuous at x equal to 1, and let us consider g r to r defined by g of x is equal to 1 by x minus 1. So g is discontinuous at x equal to 1, but the composite function g of f of x is equal to g of f of x is equal to g of f of x is sine 1 by x is equal to 1 by sine 1 by x minus 1, which is continuous at x equal to 1, because limit extends to 1, this is sin 1 minus 1, but sin 1 is not equal to 1, so this part is not 0. So the composite function g of f is continuous at x equal to 1. So statement P is true. So statement P is true. And statement Q, there exist functions f R2R, g R2R such that both f and g are discontinuous at x equal to 1, but their composite function at continuous at x equal to 1. So for statement Q, let us consider f R2R defined by f of x is equal to 1 by x minus 1, which is discontinuous at x equal to 1, and g R2R defined by g of x is equal to sin 1 by x minus 1, which is also discontinuous at x equal to 1, but the composite function g of f of x is equal to g of f of x is 1 by x minus 1 is equal to sin 1 by x minus 1 is equal to sin x minus 1 by 1 minus x plus 1 is equal to sin x minus 1 by 2 minus x, which is continuous because it is composition of two functions. Composition of two functions means composition of sin x and x minus 1 by 2 minus x. This function is composition of two functions. It is continuous at x equal to 1. It is also continuous at x equal to 1. So composition of two continuous function is also continuous. So this is which is continuous at x equal to 1. So statement Q is also true. So both statement P and Q are true. So option A is correct. Thank you.